Hello and welcome back, Math 20-2. Today we're looking at the last part of quadratic functions, or another way which we could write them out. We've so far looked at general form, which is the way that we always normally punch into our calculator, and it's the most common way of writing our quadratics. We also looked at standard form or vertex form. Now, standard form is a good way of finding where the vertex is. That's why it's also called vertex form. So if we remember, H and K gave us my vertex, which is a very good and powerful and unique situation. This one's very good for us and it's very helpful. Now our last one is in factored form. So today we're looking at factored form. Now factored form could help us with graphing as well. So eventually we're going to learn how to graph these equations and what to find without ever graphing into our calculator. We'll know how to do it and what everything means. So let's start off. Here's the investigation. I'm going to help you out with this investigation. I have a secret. I could look at this and I could solve all of these very fast. So first of all, m and n. We know that here my m is 2 and my n is 8. The x-intercepts are 2 and 8. Oops, I don't need a bracket there. And my y-intercept is going to be 16. My axis of symmetry is going to be 5, is at x equals 5. Okay? Now let's take a look at the next one. I have 2 and 6. Well, this is the same thing saying minus -2, because it's always minus m, so that's going to be -2. This is going to be 6. So my x-intercepts are -2 and 6. Well, my y-intercept is going to be -8. What am I doing to get that y-intercept? Oh, sorry, -12, not -8. It's -12. Made a mistake there. What am I doing to get that y-intercept? Now my axis of symmetry is going to be x is equal to 2. What am I doing to get that? Okay, the first part's easy, right? This part here, well, m is, well, -2. N is -6. So we have -2 and 6. -6 are my two x-intercepts. My y-intercept is going to be 12. Okay, and my axis of symmetry is going to be at -4. That's interesting. What am I doing to do that? So what am I doing to get this and this? What is this? How do I know these so fast? Some are a little bit easier than the others. Okay, now let's take a look at this last one here. We have, well, it's x really minus 0. This is like saying, this x here is like saying x subtracts 0, and we just write x. So I have 0 is 1, and the other one is going to be 4. So we have 0 and 4 are my two x-intercepts. Now, what is my y-intercept? Say 0. How do I get that? This here is when x is equal to 2. How do I get that so fast in my head? Now let's take a look at this one. This next one here is -8 and 10. So that is when we have -8 and 10 are going to be my x-intercepts. I'm going to say my y-intercept is going to be -80. Well, that's interesting. And then this one here is going to be 1. Got a lot to think about that one. Shouldn't have taken me that long. So what is my secret? What am I doing to get these? What am I doing to get these? And what am I doing to get those? That is your job right now. So you could pause and maybe come back later and figure out what I did to get those. What did you notice? What was my secret to do this? So there you have your table. What was I doing to find these especially, and these, my y-intercepts of the graph, my axis of symmetry. Okay, so here we go. Now we're on our next page, and I'm going to help you again for the investigation of 2. Just go right there. Investigation 2. So once again, I have a secret. Okay? Well, I'm going to start filling this out. I know if my a is 2, m is going to be 5, m is +5 here, and n is 2. So we have 5 and 2. Now I want to know what are my x-intercepts. Well, that's 5 and 2. Kind of similar to the one before for that one. My y-intercept, though, is going to be 20. What kind of shape is this? Well, remember which one in our graphs before did we use to find the shape? There was something there, and the variable is the same in this one. I know automatically it's a happy face. So let's take a look at this here. We're looking at negative 3. Oops, a is 4. We have negative 3, and we have 2. Well, that's negative 3 and 2 are my x-intercepts. And this is going to be negative 24 I'm going to get for that one. I'm also going to say this opens up. Okay, let's try the next one here. So we want to know this one. So I'm going to have 5, and I'm going to have 10 and negative 3. So my x-intercepts are 10 and negative 3. And this is going to be negative 150 is my y-intercept. And once again, it is opening up. So that's interesting. What am I doing? Well, let's take a look at the other one. It's very similar to the other one, but I'm adding something. What am I adding? So let's take a look at this one here. Oh, well, remember, this x is the same as x subtract 0. And then that's this x here. And then we still have the negative 3 in front. So my a is actually negative 3. It's not negative 3x. My m is 0, and my other one is negative 2. So my x-intercepts are at 0 and negative 2. My y-intercepts at 0 and it's a frowny face. What makes us frown? What kind of people frown? Think about that. Okay, next one. We have negative 10. Negative 1 and 3. So I'm at negative 1 and I'm at 3. Okay, those are my x-intercepts. My y-intercept is going to be, okay, and my last one. I have negative 1. There's an imaginary 1 in front. Okay, negative 1. I'm going to have 10 and negative 10. So that is at 10 and negative 10 are my x-intercepts. And this is going to be 100. Oh, and both of these are frowns. Something's making me frown. So what is my secret for this one? Okay. Now if we go over this, I want you to complete the following. I want you to try your best and complete B. Show me my secret, try and figure out what my secret is, and complete B. So pause and finish that part. Okay, so here we go. Class example number 1. Without the use of a graphing calculator, state the x-intercepts, the y-intercepts of the equation, and the axis of symmetry. So my x-intercepts, y-intercepts, and axis of symmetry. So let's start off with this first one here. We want to know my x-intercepts. Well, we did something with that earlier. What did I do? We're looking at x plus 4. So my m is equal to negative 4, and my n is equal to 10. So my x-intercepts are equal to negative 4 and 10. Okay? So that's done. We finished my x-intercepts. My y-intercepts is, look at these two guys right here, and I'm going to get my y-intercept is negative 40. Okay? Now the next one is we want to know the direction. Is it opening up or axis of symmetry? So it's once again looking at these two. So I combine those. So it's x is equal to negative 4 plus 10 divided by 2, which is going to give me 6 divided by 2, which is equal to 3. Okay? So that is going to be my axis of symmetry, is at 3. And is this opening up or down? Well, there's a positive in front, so it's a happy face. It is opening up. Let's take a look at the next one. Well, first of all, we want to know my x-intercepts. All that and that are my x-intercepts. Are -6 and -9. Now let's take a look at the next one. It says, what are my y-intercepts? Well, I go, this and this are related, but also that helps. So I have 54, -108. Okay? So we have to multiply all those together. -2 multiplied by -6 multiplied by -9. We multiply all of these together to get -108. Okay, now the next one is the my axis of symmetry for this one. My axis of symmetry. So, same thing. We must go -6 plus -9, and then we divide it by 2, which gives me -7.5 is my axis of symmetry. Is x is equal to that, and my axis of symmetry. And the last one is it opening up or down? Well, it's a negative, so it's opening down. It is down. Okay? So here we go. This one here. It says, we want to know if it's, first of all, what are my x-intercepts? Well, my x-intercepts are x minus 0, so 0, or 0, and 20. What is my y-intercept? Is equal to 0. Because remember, there's only one y-intercept in a quadratic. Now, is it opening up or down? Oh, sorry. My y-intercept is equal to 0. Axis of symmetry is, well, we have 20 plus 0 divided by 2 is equal to 10. That's my axis of symmetry. And my last one is opening up or down. It's negative, so it's opening down. It's a frown. It's opening down because it's negative. Okay? Now, here we go. Let's look at example number 2. Here are some examples. Write each function in the form like this and state the x and y intercepts. Well, first of all, I look at this here. I want to make it so my x's are positive. So I'm going to have to go is equal to -x plus 1. There we go. Now this will help me find my x and y intercept, but there's still -x there. So if I take out and multiply this by -1, take out a -1, if I factor out of this -1, divide by everything by -1, I'm going to get -1, and I get x minus 1, because the -1's right there. I just divided everything by -1. I could do that, as long as I multiply it in later. Multiply this, it gives me that, x minus 10. So, now what are my x and y intercepts? My x-intercepts for this one is 1 times 10, or is 1 and 10? Is 1 and 10. My y-intercepts is 1 times 10, then times -1, is equal to -10. Okay? That's all it wants us to do. So let's take a look at this next one here. So we have the same idea. We have y is equal to -3, and I want my x to be first. So -x, and I have minus or plus 4, and -x plus 12. Well, I look at this here, I don't like this negative in front, so what am I going to do? I'm going to divide all of this by -1, and I'm going to divide all this by -1. So I end up taking out a -1 from both. -1 times -3 multiplied by -1 is equal to x minus 4, because both of these are divided by -1, and both of these are divided by -1, x minus 12. This is going to give me -1 times 3 is positive 3 times -1 is -3, and I get x minus 4, x minus 12. So my x-intercepts are 4 and 12. My y-intercept is 4 times 12 and multiplied by -3. 4 times 12 is 48. Multiplied by negative 3 is going, or 12 times 12 is negative 144. Okay? And that's everything. That's how we do that. All right. So here we go. Our third example now. So it says, each of the graphs are in the form a x minus n, where a, m, and n are integers. Match each equation. Okay, so this one right here is saying x minus 1. So that means my x-intercepts are 1 and negative 4. So which one has x-intercept 1 and negative 4, and it's 2, so it is going up. Happy, 1 and negative 4. Negative 4 and 1. So this is graph D. See how I did that? Look at this one here. I don't like how that's rearranged, so I'm going to rearrange this. And I know it's the same thing as negative 1. I have x, negative x, minus 1. And we have negative 1. And we have x. Oh, I don't have to do that. Sorry. Made a little mistake there. I could just rearrange this. So it's just x plus 1. And then we have to multiply negative 1. I'm taking out a negative 1 from here, factoring out a negative 1, so I end up getting x minus 4. Okay? So really, I have negative 1, x plus 1, x minus 4. So let's see how that works. So we have 4 and 1, and it's down. So it's at 4 and 1 and opening down. So 4 and 1 opening down. So it's a smiley face and 4 and 1 and opening down. Hey, look at that. That's perfect. So this is graph B. Let's try the next one. Oh, this is simple. First, it's positive in front, so it's a happy face. Well, we pretty much know it's graph 8, but let's double check. Negative 1 and positive 4. Negative 1, positive 4. So it's graph 8. And the last one has to be the last one, graph C, but let's double check. Is it opening down, graph C? Yes, opening down. Now it says my intercepts are positive 1 and negative 4. Positive 1, yes, and negative 4, yes. So it's graph C. So I'm pretty sure I didn't make a mistake. Okay. Now, there we go. It says, the graph represents a quadratic function with the equation of this. Okay, state the x and y intercepts are shown on the graph. So we have the x and y intercepts. So what are the values of m and n? M is equal to 3 and n is equal to 3. Explain how to determine the value of a. Well, a is, we know, is positive. A is positive. We know that because it is a happy face. Okay? So 1 there is a is positive because it's a happy face. Now we want to look at the next part here. How else can we determine the value of a? Well, we know it's positive, it's a happy face, and we know another point on it right here. Okay, so we know another point. So all I'm going to do is, we know y, we know that if our formula is y is equal to a, and we have x minus, oh, 1's 6, not 3, I mean minus 3, and then x plus 6, or minus 6. Those are my two intercepts. And we know the value for x, when x is 0, y is 36. So let's put that in. We know when x is 0, y is 36. So we know 36 is equal to a, and then we have 0 minus 3 multiplied by 0 minus 6. This will help us solve for a. Now we know everything except for a. So I get a is equal to negative 3 times negative 6 is 18. So it's 18a is equal to 36. And I solve that, divide both sides by 18. And I'm going to get a is equal to 2. Next part says, write the equation of the graph in that form. So now that we solve for a, we could write it in that form. So we get y is equal to 2x minus 3, x minus 6. Determine the coordinates of the vertex. well, the vertex, my x-coordinates are obviously just below. So we can first find the axis of symmetry. Because we know the vertex is at the axis of symmetry. So that is just going to be 3 plus 6 divided by 2, which is going to give me 9 over 2. So now we want to find the y value at 9 over 2, because there's only one value at 9 over 2. So we plug that back into there. So I'm going to get y is equal to, what was my a value? 2, 9 divided by 2, minus 3, and then I multiply that by 9 over 2 minus 6, because we just have to find the y value at that point. And I end up getting y is equal to negative 9 over 2. So my vertex is 9 over 2, comma, negative 9 over 2, or 4.5. Alright, last one. Write the equation of the graph in the standard form. So now we're switching, but I know my vertex. So we know A is A is the same, but H and K, we found H and K. Okay, so this is great. So I get y is equal to 2x, and we minus h. H is my line of symmetry. So minus 9 over 2, that's all squared, and it's minus, so plus negative, 9 over 2. And that's it. Okay, hopefully you understand that. And we have one last question to go here. It says, determine the coordinates of the graph for the quadratic that passes through this point, and that point. So we have here our two x-intercepts. So it's kind of like the ones before. So we know my two x-intercepts. So y is equal to, this is my m, and this is my n. A, x plus 8, or minus negative 8. Minus negative 8 is how we got that. And we have x minus 2. Okay, so that's good, but now I don't know my a. So to find my a, I need a third point, and that's my y-intercept. So I'm going to say 48 is equal to a, okay, and I'm going to put in 0 plus 8, and then we have 0 minus 2. So really, it is this multiplied by this must give me 48. This is the y-intercept. So 8 times 2 is negative 16. A is equal to 48. So then what is a equal to? Divide both by 16, divide both by 16, negative 16. A is equal to negative 3. So my formula, I put this back in, I'm going to get y is equal to negative 3, x plus 8, x minus 2. Okay? So that's how we do that one. Hopefully you understood this, and I'll see you tomorrow as we tackle the assignment together.